Our project is about controlling and tracking model train systems. And so I'll start by introducing our team. My name is Leanne Hanback. We have John Chambers and Sunny Patel and Scott Schiavone.
So the purpose behind OnTrack was an infrastructure in order to build a positive train control system for UAH. Dr. Kulik teaches software safety course, and he wanted a platform where he could build on top of what we build in order to actually remotely control and track the trains. Positive train control is the government mandate having all real locomotives having remote control and tracking.
We feel our project has pretty much everything. Hardware design, software development, we have hardware and software co-design, embedded system programming. So if we can just look at from this hardware perspective, we have a couple of custom PCBs that we have developed by ourselves. And one of them contains the IMU and takeout count sensor on top of it. From the software design implementation, our main concern or main goal throughout the semester was to get the motion tracking with the drift correction. And as far as the co-design goes, to putting everything together, the integration of the system itself.
So this is kind of just a big picture overview of our entire system. We have 4 major components, the first one being a tablet application that's written in Java for Android tablets. We also have a wireless controller, which is a piece of hardware that we designed ourselves. And then we have a sensor board, which is another piece of hardware. It's a custom circuit board that actually mounts behind the trains. And then we have our track. And so the track is more than just the actual rails. We also have these commercial off-the-shelf control boxes that we are actually interfacing with. So this is more than just a simple interface. There's actually protocols going on here. So kind of like the way it works is the tablet application communicates to the wireless controller over Bluetooth. So the user can select trains, control trains, and all those commands are handled through Bluetooth. And then the wireless controller kind of acts like a gateway to communicate between the tablet and this other hardware we have. And the way that it communicates is we have the wireless controller talks to the sensor boards over a wireless link. We have these small low-power radios that are in each of the locomotives. And then the wireless controller, John had just mentioned some of the protocols that it used. It communicates to the track over DCC and LocoNet. DCC is used for controlling the trains. LocoNet is for controlling those commercial off-the-shelf switches that we were talking about. Okay, so this is just kind of an overview of our actual circuit board. We have a nice video here. This was custom designed by all of us for this project. It receives commands over Bluetooth, like I was talking about, and it controls the DCC packets and LocoNet packets. This is the DCC control, and this is a connector for LocoNet. And it also controls the data flow between it and the sensor boards that are on each of the trains. So it will request packets from each of the trains that it's talking to. And then this is our custom board for each of the trains. This is what we're calling our sensor board. It runs on a 9-volt battery, and then we have it right over here if you'd like to see it afterwards, but this is what actually gets mounted inside of a small train car that is pulled behind the train engine. And so it has a place where it will, there's one of these per train, and we can control multiple trains, so we can track multiple trains. And then it has an inertial measurement unit, and it also has a tie counting sensor on it.
We were recording this, we were recording off the Android tablet. It's kind of difficult to get good recording software for free, and what I ended up using was something that just basically pulled screenshots. So it's a little jumpy between different. Put this into a video. So we'll be pausing here and there and kind of explaining what's going on. So right here I'm actually opening the application. If you'll pause and go back just a moment so I can explain the UI if you don't mind.
Just make it all the way in there.
Alright, so what we have here is just a pretty plain looking UI currently. On the bottom left, if you step up, Sunny, you'll see 3 icons. This is drag and drop, so you can drag up into the large blank area a train, a switch, or a barcode. On the bottom right, you can see Add Layout. This is where you actually add your layout image. Connect, which will connect to the Bluetooth device. And on the upper right, you'll see drop-down boxes for trains and switches. This is just another method of selection. We also have it where you can select on the layout. Sadly, it's hard to capture the actual clicks when I'm doing this recording, so I just kind of want to go through what we're doing. And on the right, we have a vertical slide bar, which is basically your throttle. Center is at stop, all the way up is full speed forward, all the way down is full speed reverse. So we have a picture-in-picture of the track while we're doing this. I'm going to add trains 3, 4, and 5 after connecting to the Bluetooth device. If you look here, I have train 3 here, 4 here, and 5 over there. And as you can see, as I'm placing trains onto the layout, I'm entering a number in and then hitting OK, and that puts it. Then, after selecting 5, you can see it's the default device. I click on 3 and then move its throttle in reverse, and it starts moving. Then I select 4 and then move it forward, and it starts moving. This is just showing the control. We don't have a layout here for tracking, and that comes in the next demonstration. And 3 is now moving forward. And I'm about to delete 5. Once you delete a train, it sends it a message to stop. That way you won't have any crashes with that. So I hit delete, it confirm the deletion, I delete 4 also, and then finally I delete 3 once I have it in the proper spot for the tracking demo. It's a little easier to set it up when it's parallel with the edge of the table. So if have it parallel, the yaw can either be 0 or 180 and then go from there. If I have it off, I actually have to measure the angle exactly when placing the train, but that is something that we've programmed in. We select Add Layout, then choose the gallery. I probably should have hid the video. Then I choose the layout, and I enter in the height, the width in inches, and this large number is the calculated tie spacing in inches. So we used a caliper and we went very far. And basically how we got that, we measured several and divided over the duration. Okay. And now we go to the tracking. What I added here was, I added a barcode right here, which corresponds to right here on the track. This barcode reads 2 as you read across it. Then I add train 3 to the location that it is on the track, and as you see, I then add 180 because it's actually going left instead of right. Like I said, you can have it in whichever orientation. I then proceed to move it forward, and we're moving forward. The tracking, like I said, is very jumpy because the Android recording is much more smooth in person. Once we get here, we start getting a little bit off, especially right here. You can see it kind of going on and on and on, and it's a little high. Once it reaches the barcode, it then snaps to, but you have your offset after the barcode, and it corrects it.